In this video, we are going to finish up our discussion of section 11.3, the dot product, with something called the directional cosines. Take a vector v and put it in space, as you can see in this picture. What we're looking at here is we are looking at the angle between our vector and each one of our axes, or I guess even better with our standard unit vectors. So if you notice this alpha here, alpha is the angle between v and the x-axis. Another way you could think about this is if you were to take vector v and like rotate it around x, like revolve it, the angle that cone, it would make a cone, right? Think about v revolving around the x-axis. The angle that would be from the middle of the cone to the outside of the cone, that is alpha. Now, if I were to take v and revolve it around the y-axis, beta is the angle that it creates with the y-axis. And then gamma, being this Greek letter here, is the one made with the z-axis coming down. It's kind of strange that it's coming down, but it's still a positive direction. Now, if we were going to think about this, first let me write out what those are called. Alpha, beta, and gamma, do your best gamma, are the directional cosines, of v. That's how we'd say it. Now, how would we find that? Well, if I'm trying to find the angle between v and I, both of those are vectors, so I actually can just use our definition. Cosine of theta is v dotted with I all over the magnitude of v times the magnitude of I. I should have a hat, not an arrow. Okay, but we can simplify this. This is the same thing. Okay, cosine theta equals, okay, if I take the dot product with v, all right, so let's imagine that v1, v2, v3, and we're going to dot it with I is just 1, 0, 0. If I dot that, I just get v1. Make sure you understand that. So up top, I just got v1. It's not even v anymore. It's just the component, first component of v. The bottom, this thing, the magnitude of I, sorry for the shifting there, that's just since it's I is a unit vector, then the magnitude is 1. So we just have cosine, and it's not theta, be cosine of alpha. Right? It's that formula, but the actual angle is alpha. So we have cosine of alpha is v1 over v. You can actually probably take a guess. I would pause it, maybe see if you can do it. Cosine of beta is equal to v2, the second component, over the magnitude of v. And cosine of gamma is equal to v3 over the magnitude of v. These are called the directional cosines. You can use these formulas to find the angle between. You can find alpha, beta, and gamma. We rarely use these, but they're here, so you know they exist in case something in your field brings these up that I'm unaware of. So, which could totally happen. All right. The one last thing that, and we're going to do an example and then we'll finish, but there's one other thing with these that I'm just going to give you, and if you're interested in a proof, it's really not hard. I would just consider what each one is equal to and plug them in. You can totally do it. Plug them in by the definition, and you can show that all three of these will be equal to 1. If I take each one of those and square it, I'd equal to 1. What you're going to want to do to prove that, if you want to prove it to yourself, is plug this in right there and do that for each one. If you do that, it should equal to 1. All right, let's finish off with an example here. It's pretty straightforward. We have v. I'm going to rewrite it in its component form because that's what I prefer. -1, 3, 5. All right, it says find the directional cosines. Well, if I take a look at all three definitions there, I definitely need the magnitude of v. So the magnitude of v is the square root of the sum of the squares. All right, this ends up being, if you do it in your calculator and work it out, this turns out to be the square root of 35. All right, so I'm going to set up these equations, but I'm not going to solve them because I believe you can do trig, I hope. Cosine of alpha is equal to, -1 over rad 35, and we would just solve for alpha. Cosine of beta is the y component, 3 over the square root of 35, and then cosine of gamma is the third component, 5 over the magnitude. And then we would just take inverse cosines and solve for each angle, and that would be it. Like I said, these show up very, very rarely, but it's worth going over because it took us a few minutes.